So this question has been asked in the contest of the 31st March. So the question is count alternating subarrays. Okay, and it has been marked as medium question, medium level question. So what we will see is you are given a binary array nums. So an array nums is given. We call a subarray alternating if no two adjacent elements in the subarray have same value. Right, return the number of alternating subarray in nums. So pretty much basic simple question is there. So for example 0 1 0 is 1 1 is this is the array, then what are the array which are possible? So simply first 0 1 1 1, all this will be the in our answer, these will be the subarray, and one more which can be there is 0 1. Why not 0 1 1? Because 1 and 1 alternating elements have the same value, right? So you need to find those elements which have those subarray which don't have the similar number as the adjacent one. For example, let's see one more example. So it's written 1010. So 1011. These four will be the first in our answer, and then from here onwards, the more answer will be 10, then 101, then 1010, then again 010, then 01, and then 10 will also be there. So total 10 will be our answer in this case, right? So let's see what's gonna be the approach. So first I will say the pretty basic thought which should come in your mind is you will traverse the whole array and find all the elements which have at least adjacent elements are not same. So first what you will do, the brute force is you will start from 0 and you will start from 0 and you will start for first loop, and inner loop will be start from I plus 1, right? And you will check if nums of j is equal to nums of j minus 1. That means the two elements have same value. That means you cannot find a subarray which is bigger than this, right? So you need to break, else you will do a count plus plus. For example 0 is here, 0 1 you will have a count plus plus, right? In this example 0 1, again 1 j will go to this pointer, and at this pointer you will fill and it will come out of the loop for this example, right? Then again it will go up, again it will check, and ultimately you will return the total number of subarray which are possible from this by this example, this for two for loops, right? But in this example, what will be your time complexity? The time complexity will definitely be, not definitely, but almost it will be near to O of n square, and you need to optimize it, because if you will run from this loop, you will definitely get a time limit exceed, right? So you need to do it under O of n. So how you gonna do it? So first we will define int l, left array and right, left array not array, left pointer and right pointer, left at 0 and right at 1, right? I will show you this with an example. First you see the code. So while r is less than n, so what I am checking is if nums of r is not equal to nums of r minus 1, that means 0 is not equal to 1, then count equal to count plus r minus l. Why this? I will also explain this also, don't no worries. Else if this not the case, then you simply move the left pointer to the point where r is standing, and at every case you increment the r value, right? And at the end you return n plus count. Now why n plus count and why all this? Count is equal to r, count equal to count plus r minus l. Why all? I will explain this. But count equal to count plus r minus l is pretty simple, right? Your r point is over here, let's get right, and l pointer is over here. So the number of subarray which are possible according to you will be count any value plus r minus l. So it will give you the subarray which are between the range, right? So let's see, and why we are doing, and also let's a pretty basic example, because all those subarrays like 4 are there, these 4 also will be the answer, means 1 0 1 0, these all 4 subarray are also our answer. That's why we are returning n plus count and 1010. Why? Because we are starting the value from 1 and 0, and these two will not be included in our subarray, means 1 will not be in our subarray, 0 will alone 0 will not be in our subarray. That's why we are doing n plus n. But if not clear, I will try do the diagram. You will understand at that place. Okay. So the given array is 1 0 1 0. So our left pointer will be at 1 at this place and right pointer at this place. So we will first check if the nums of r and r minus 1 are the same. As they are the same, the count value will be equal to count plus r minus l, that is 1, right? Then the r pointer will move to this point and r will become 2. And again it will check, is 0 and 1 same? No. Then again what will be the value? 1 count plus r minus l, that is 1 plus 2 minus 0, that is 3, right? And again the r will move to this point, and at this point the count will be 3 plus 3 minus 0, that is 6, and r will now move out of bound, that is r will be not greater or it is equal to n, right? And the loop will end here. So the total count is 6, and as you see we are adding the total size of array plus the count value which you have got here, that is here for example 6, so it will give me 10, right? So why are we adding 4 here? Because all the sub-array which are the single integer like 1, 0, again 1 and again 0, these are being not included in our answer as we are moving our right pointer from one place ahead of its value, right? That's why all the values are all these four or the size of the array is not being included in our answer. That's why we are doing a 6 plus 4, that is equal to 10, or the answer which have come plus 4 as answer plus nums dot size as our final answer, and we are returning it. So I hope you have understood the concept why we are doing it. So if you don't get it, you can answer in the comment section.